Hi everyone. Today I am going to discuss about data types in Python. There are 14 data types in Python: int, float, bool, complex, str, bytes, byte array, range, list, tuple, set, frozen set, dict and none. These 14 data types are categorized into 6 types. First one, fundamental category data type, sequence category data type, list category data type, set category data type, dict category data type and none category data type. Int, float, bool, complex, these four comes under fundamental category data type. Str, bytes, byte array, range, these four comes under sequence category data type. List and tuple belongs to list category data type. Set and frozen set belongs to set category data type. Dict belong to dict category data type and none belongs to none category data type. Today I am going to discuss about detail in fundamental category data types. Um, the function of fundamental category data types is to store single value or elementary value. There are four in fundamental category data types: int, float, bool and complex. First of all, coming to int is one of the predefined class and treated as a fundamental category data type. The purpose of int data type is to store integer values or whole numbers, the numbers without decimal places. These are stored, and by using int data type we can also store number system data also. In Python we have four types of number system data. First one, decimal number system, binary number system, octal number system and hexadecimal number system. Coming to binary number system, these are understandable by OSs and processors. It consists of two digits, 0 and 1. So it consists of base 2, and all the base 2 literals are called binary number system data. When we store the binary number system data, the binary number system data must be preceded with 0 small b or 0 capital B. And coming to decimal number system is a default number system. It is understandable by all the human beings, and it consists of digits from 0 to 9, total 10 digits. So it consists of base 10, and all base 10 literals are called by decimal number system data. It is default number system data. Even the programmer can give the data in the form of binary, octal or hexadecimal, PVM directly converts into decimal number system data automatically. And coming to octal number system, these number systems are understandable by microprocessor kits, and it consists of digits from 0 to 7, total 8 digits. So it consists of base 8. And when we want to store octal number system data, and with the octal number system data must be preceded with 0 O small o or 0 capital O. And coming to hexadecimal number system data, these number system are used in development of OSs. It consists of values digits from 0 to 9 and A to F. A is internally called 10 and B is 11, C is 12, like that. 15 is F. And when we want to store hexadecimal number system data, it must be preceded with 0 small x or 0 capital X. And that's it about int data type. And coming to float data type, float is one of the predefined class and treated as a fundamental category data type. And the purpose of float data type is to store integer values, real construct values with the numbers with the decimal places it can be stored. And by using float we can also store scientific notation data also. The advantage of scientific notation data is to save the memory of to save the memory when we are using large volumes of floating point numbers. And yeah, that's it about float. And coming to bool is one of the predefined class and treated as a fundamental category data type. And the purpose of bool data type is to store true or false. True and false are keywords. Internally, true is treated as 1 and false is treated as 0. And coming to complex data type, complex is also one of the predefined class and treated as a fundamental category data type. The purpose of complex is to store complex data. The complex data is in the form of a plus bj or a minus bj, where a is a real part and b is a imaginary part, and j is a j is equivalent to square root of minus 1. Internally, these real and imaginary parts in complex data can be treated as float values, and we want to get real and imaginary parts. We have two attributes, they are real and imag. When we want a real part, we use real attribute, and we want imaginary value, we will use imag attribute. And coming to the base conversions, we have three base conversions functions, that is binaf, octaf and hexaf. Binaf is used for converting the data from decimal or octal or hexadecimal into binary. Then we will use bin function, and oct function is used to convert decimal, binary and hexadecimal data into octal number system, octal data. So we will use octaf function. And hexaf. Hexaf is used for converting decimal, binary or octal number systems into hexadecimal data. So we will use hexaf function. That's it.